So we've all been there, right? You build this amazing LLM prototype in a Jupyter notebook. It works, it's cool, but then you hit a wall. How do you turn that experiment into a real, reliable application? Well, today, that's exactly what we're going to tackle. We're building the bridge from messy notebooks to a professional, production-minded workspace. Let's jump right in.
Here's the game plan. We'll kick things off by talking about why LLM development is just different. Then, I'll walk you through a structured, 4-layer platform to keep things organized. We'll build out the core stack, layer on the essential ops tools, map out a practical project blueprint, and wrap up with the most critical piece of all, adopting a professional mindset.
All right, first things first. If you're coming from traditional machine learning and think you can just use the same old setup, you're in for a surprise. The tools, the workflows, even the way you need to think about a project has fundamentally shifted.
I mean, just look at the difference here. On the left, you've got your classic ML setup. Pretty straightforward, right? Python, notebooks, maybe a library like scikit-learn. But on the right, welcome to LLMOps. We're talking about a whole new world of complexity. You've got prompt engineering, you're juggling APIs from multiple model providers, and you're working with new tech like vector databases for RAG. That's retrieval augmented generation. It's not just about training a model anymore. It's about building and managing an entire system with a ton of moving parts.
It can feel like a lot, I know. So the big question is, how do you manage all this without getting totally lost in the weeds? The answer isn't just to throw more libraries at the problem, it's about having a structured approach right from the get-go.
And that brings us to a mental model that is going to save you so many headaches. I want you to start thinking about your dev environment as a 4-layer platform.
And here's how that breaks down. Think of it like building a house. Layer 1 is your foundation, the core developer tooling, the absolute must-haves. On top of that, we add Layer 2, the specialized LLM and data tools. This is where the magic happens. Then Layer 3 is where we get serious about making it robust, with ops and reliability. And finally, Layer 4 wraps it all up, keeping it secure and configurable. This isn't just a random list, it's a blueprint for building something solid.
Okay, enough theory, let's actually start building this thing, layer by layer. We'll start with the first two, the core and LLM stacks. This is where your app is really born.
Layer 1 is your bedrock. These are the non-negotiables. You need a modern Python version, a solid code editor like VS Code or PyCharm, and absolutely, positively, you need Git for version control. And seriously, get Docker installed right away. Even if deployment seems far off, it forces you to think about creating reproducible environments from day one. Trust me, you'll thank yourself later.
Now for the exciting stuff, Layer 2. This is where we bring in the LLM-specific toolkit. You'll grab the SDKs for whatever models you plan to use, whether it's OpenAI, Anthropic, or Google. You'll need a good library for creating embeddings, and a local vector database like ChromaDB is perfect for getting started with RAG. And then, frameworks like LangChain or LlamaIndex help you orchestrate it all.
You know what? Let's pause here for a second, because vector databases are a real game changer. So what is one? The best way to think about it is as a search engine for meaning. It doesn't just look for keywords. It finds chunks of text that are conceptually similar. This is the core technology that powers sophisticated RAG systems, letting your LLM pull in relevant, up-to-date information to answer questions. It's super powerful.
Feeling ready to get your hands dirty? Here you go. This one command is your starter kit. Seriously, this single line gets you a web framework, LangChain for orchestration, the OpenAI library, embedding tools, a vector DB, and a way to handle your secret keys. It's a fantastic starting point.
Okay, so we've got our core tools installed. But an application you can't see into, one you can't debug or monitor effectively, well, it's basically a black box, a ticking time bomb. That's why we have to move up the stack to layers 3 and 4, the ops and reliability layers.
This right here is where we make the leap from being a hobbyist to being an engineer. Layer 3 is all about visibility. You absolutely need logging to see what your app is doing in real time. You need experiment tracking to remember which prompts worked and which ones didn't. And you need monitoring to watch for performance bottlenecks, errors, and critically, your token usage costs, because those can sneak up on you fast.
And look, you don't need some massive complex system to get started. This example uses Python's built-in logging module. This one simple line gives you a structured log telling you exactly what prompt was sent to which model. This is infinitely more useful for debugging than just a lonely print statement.
And that brings us to Layer 4, which is all about managing your app's configuration and secrets safely. I'm going to say this once, nice and loud. Never, ever hard code your API keys into your code. Just don't. Use a .env file for local development and start planning for different environments like staging and production from day one.
This is all it takes, a simple text file named .env. Your code will read these values from the environment, which keeps your sensitive keys safely out of your source code. Plus, it makes it a breeze to change your configuration when you move your app to a new server.
All right, we've talked about the 4 layers in theory. So what does this actually look like in practice? Let's put it all together in a reusable project structure.
This is how those abstract layers become a concrete project folder. A template like this gives everything a proper home. Your messy experiments? They live in the notebooks folder. Once your logic is stable, it graduates to this source folder. Your API lives in app.py, and your dependencies and Docker config are right there at the root. This is the kind of organization that lets you scale without wanting to pull your hair out.
And here's how you actually bring your LLM logic to life for the outside world. Using a simple web framework like FastAPI, you can create an API endpoint in just a handful of lines. Now, instead of being trapped in a script, your LLM is a service that any other application can talk to.
Now, if we peek inside that call LLM function, it should look something like this. And you see those logger calls before and after the API request? That's our Layer 3 tooling in action. You now have a clear record of every single prompt sent and response received. This is absolutely invaluable for debugging, evaluation, and just understanding what your app is doing.
So we've covered the tools, we've covered the structure, but honestly, the biggest change, the biggest leap you have to make is in how you think. It's about shifting your mindset from being a tinkerer to being an engineer.
I want this quote to stick in your head. Platform first, experiment second. What does that mean? It means you build the solid, reliable, reusable foundation before you get lost in 100 different prompt experiments. Because when you run those experiments on a proper platform, they'll be faster, more reliable, and you'll actually be able to trust the results.
And this slide really just sums up that entire mindset shift. It's about graduating from print statements to structured logging, from hard-coded API keys to config files. And it is definitely about moving away from files named final_version3_I swear this is it.ipnyb to proper version control with Git. This is the fundamental difference between a project that only works on my machine and one that's actually ready for the real world.
So as you start your next project, I want you to ask yourself this one simple question. Are you just building another one-off experiment, or are you laying the foundation for a robust, scalable platform? Because the choice you make on day one will define the entire future of your application.